Hi everyone, today we are going to be discussing the interval convergence for converging series. This follows several relatively simple steps to find your exact interval of convergence in an inequality form. So to begin with, you take your original series and you find its radius of convergence using the ratio test. From there, you just do some relatively simple algebra to give yourself an interval of convergence. And then what the purpose of finding the interval of convergence is to determine whether these endpoints are included in your interval or not. So what you do is then you take these endpoints and you plug them each into the x of the original series. And so then you have two new series to determine the convergence or divergence of. And generally at this point, the ratio test becomes inconclusive, so we'll explore a couple other options for that. And if the series converges at one of the endpoints, then the endpoint is included in the interval. But if it diverges at an endpoint, then the endpoint is excluded from the interval. So we're going to run through just a couple questions. This is relatively simple, and it'll be pretty easy to understand. Okay, so the first example that we're doing is x plus 3 to the n all over n. So to begin with, we'll use the ratio test to find the radius of convergence. So what we'll do here is the limit as n approaches infinity of x plus 3 to the n plus 1 all over n plus 1, and then times n over x plus 3 to the n. And that's the simple ratio test that we should know. From there, this cancels out into an x plus 3 to the first. Oops, sorry, that needs to be 1. X plus 3 to the first times n over n plus 1, still the limit as n approaches infinity. And so from here, you can take this x value out. I just like to do that for simplicity. And you get x plus 3 times the limit as n approaches infinity of n over n plus 1, which we know of this to equal 1 when n approaches infinity. So you're left with x plus 3. And so you find when the absolute value of x plus 3 is less than 1, which means that x plus 3 is less than 1 and x plus 3 is greater than negative 1. And then you get that x is less than negative 2 and x is greater than negative 4. So from here we need to determine whether these endpoints are included in the interval or not. All right, so now we have our two x values and our original series. So let's start by checking this x equals negative 4 value. So we plug that in for the x, and we get negative 4 plus 3 to the n all over n, which is the same thing as negative 1 to the n all over n. So this we know as the alternating harmonic series, which is a converging series. So therefore, series converges and negative 4 is included in the interval. Now if we take the same thing for negative 2, we have the series negative 2 plus 3 to the n all over n, which is the same thing as 1 to the n over n. And from here, this value on the top will always be a 1 regardless of what n value you plug in. So you can simplify this equation to 1 over n. And this is what's known as the harmonic series. And we know that 1 over n always diverges. So -2 is not included in our interval of convergence. So then our final answer, if we write it out like this, would be -4 is less than or equal to x, which is less than -2. And that's your full interval of convergence. Okay, we are going to a second example, which is the series -1 to the n times x to the n all over 4 to the n times the ln of n. So we'll start by applying the ratio test like we did before. So this is the limit as n approaches infinity of x to the n plus 1 all over 4 to the n plus 1 times the ln of n plus 1 times 4 to the n times ln of n over x to the n. So if we simplify this down a little bit, the x to the n's cancel, the 4 to the n's cancel, and you're left with an x over 4 times the ln of n over the ln of n plus 1, limit as n approaches infinity. So from here, when you plug in infinity into the n's, this 1 ends up becoming obsolete, and so these are equal, so therefore the limit as n approaches infinity is 1, and you're left with an x over 4 less than 1 to find your radius of convergence. And so from there, less than 1 and x over 4 is greater than -1. So you multiply the 4 and you get that x is less than 4. And then when you multiply the 4 over here, you get that x is greater than -4. So we're going to test the endpoints right here. All right, so for testing the endpoints, let's first plug in 4 for the x. So we get the series -1 to the n times 4 to the n over 4 to the n times ln of n. So both of these 4 to the n's cancel. You're left with -1 to the n over ln of n. All right, so this meets the criteria for an alternating series and thus converges at this point. So 4 is included in your interval. We'll test -4 next. For x equals -4, we're going to apply a comparison test to 1 over n. So when we plug in -4, we get the series -1 to the n times -4 to the n over 4 to the n ln of n, which simplifies to 1 over the ln of n. Because these, if both of these values were negative, they would cancel and then cancel with the 4 to the n in the denominator. So you're left with a 1 and then the remaining ln of n. So in this series, we have n is greater than 2, or greater than or equal to 2, excuse me. So for this comparison, we're going to use 1 over n compared to this 1 over ln of n. And for values greater than or equal to 2, 1 over n is less than or equal to ln of n, which means that by comparison, this series diverges. And -4 is not included in the interval of convergence. So therefore, your full answer with 4 included and messed that up, sorry. With 4 included and -4 not included, you get this full interval. We go from least to greatest, and this is your answer. Thank you so much for watching. I hope you found this helpful.